Okay. That was harder than it needed to be. Sorry I'm late. I needed to fix my YouTube stream key. So I'm going to verify I'm on, and then I'll start doing things. So again, sorry about being late. I had some technical difficulties that should be worked out now. My stream key got corrupted or changed or something when YouTube switched over to a new setting, but I fixed it. And yeah. Live now. Cool. Found me. Your mic is pretty quiet. Huh. I can turn that up. Try that. Hello, hello. So far, mostly students who are not in my class. I should join Mrs. Kruzich's Zoom class. No, I'm chilling. Don't really want to join her class. Oh, the stats one is going on right now? Crud. I need to figure out how to not overlap with Kruzich. Oopsie daisy. Matthew, when did that start? Out of curiosity. Because stats and calculus overlapping is not going to be good for me. And I can go later, no problem. Do 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 do. Ba, ba, ba. Hello, hello. Will this be posted later? Yeah. It started at 11:30 and she said it would be done by 12, and we're still on the first of two questions. Okay. So, Calc Kiddos, we might move later. If Kruzich is going to go at 11:30, maybe we plan for 1 o'clock to avoid the stats overlap or whatever. But this is a little unfortunate. Dang it, dang it, dang it. I tried to go a little later because I thought some of the other folks would want to go earlier in the day, but Kruzich would definitely be later anyways. Alright. So, future streams are going to be at 1 p.m. now. Wow, my schedule is so busy. It was so hard to update that. I failed Calc 4, Kennedy. Oh, sorry, Chappelle. It's possible to do both. Yeah, I mean, Matthew, you've already taken Calc, and stats is super duper hard for somebody who's taken Calc BC already. Oh, you skipped Calc 3. But you should have covered most of Calc 3 in Kruzich's class, although if I remember right, you didn't do much in Kruzich's class. Alright, so I was going to begin with some stuff, and we'll see if the calculus kiddos show up, and maybe we get fewer of the repeat kiddos asking questions or visiting. Alright, so I prepared a couple things. I'm happy to talk about questions from either of the assignments, but this is what I prepared. So first thing is we have no idea what the AP test looks like. If you go on the website and look under AP Calculus AB, we know that it doesn't have areas and volumes, so I'm not doing areas and volumes, which means we have officially covered everything so far. This is all stuff we've done so far, chapters 1 through 7. And Unit 8 here is Chapter 7 in our book, which is area and volume. So we know that's not happening. We were told it was going to be about 45 minutes long. We were told it was going to be online and secure. I have no idea how they make online secure. Like, I have no idea how they don't keep you from texting each other while you're taking the AP test. I would recommend not doing that because they'd probably catch you and wreck you if you do that, but I don't know how they check you. So I assume we're going to get more details about that on April 3rd. But yeah, under what the test looks like, we have star, star, and star. And they say it will update April 3rd. So I don't know what the AP test looks like. I'm just going to prepare people for calculus and not worry too much about the AP test until we know what it looks like. All right. So, moving down. Right, I'm in screen capture. I just snagged a DiffyQ problem. Just out of curiosity, people in my class, have I done this question this year? I didn't think so, but we may have. I'll wait a second and see if chat is like, oh yeah, we've definitely done this one. Chappelle, any more Fortnite and you're gonna get banned. We got a no. I don't think so. I don't know. Yeah, I mean, if we've done it, it's been a couple weeks, so it probably doesn't hurt anyway. So seems good. All right. So yeah, this is just a differential equation free response question. So first things first. In our first part of the question, it says we have the slope field below, and we need to sketch the solution curve through 0, 1. So 0, 1 is right here. And all we have to do to sketch the solution curve is draw what the graph looks like it's going through, which is like bloop, bloop. And that's it. Cool. 1 point through the question. All right. For part B, it says, write an equation for the line tangent to the solution curve in part A at the point 0, 1. So we're looking at this point. So we need to find the slope at that point. And to do that, we just plug in 0 and 1 into our differential equation, because our differential equation's output is the slope. And we get 3 minus 1 for 3 minus y times the cosine of 0, which is 1. So our slope is 2. Sweet. And now we just do y equals 2x plus 1. I do point slope form like I normally do, but we were given the y-intercept, so y use point slope form. Sweet. Then we use the equation to approximate f of 0.2, so we just plug in 0.2 for x. And we get 1.4, which is our new y. And sweet. That's the entirety. This was worth a point, and this was worth a point. 3 points into this 9-pointer. And yes, Ivan, I'm moving it to 1 o'clock. I didn't know that Kruzich was going to stream at 11:30. So, yeah, I have no problem moving later. My schedule is amazingly busy right now. It's just video games, eat, work out, video games, eat, and then sleep. Wait, where is the point 2? Oh, the point 2 comes in part B of the question. That's on the page for sure. And yeah, it's right there. Sweet. Okay. Next part. It says find y f of x, the solution, particular solution to the differential equation with the given initial condition. So this is the bread and butter. This is a 6-pointer that's coming up in part C here. So point number 1, separate variables. In our initial differential equation, I need to get the y's on one side and the x's on the other, so I get dy over 3 minus y equals cosine x dx. We integrate both sides. The right side is almost always easier to integrate. Whoops, not cosine of x plus c. Or dx, it's cosine or sine of x plus c. Because cosine integrates to positive sine. The derivative of cosine is negative sine. On the left, we're a little bit sad panda here because we have to do like u substitution or account for the chain rule because the derivative of the bottom is not 1. So while we get a natural log of 3 minus y in absolute values, we actually get it over negative 1, and we could do u substitution to show that, or because it's just a number, we can just divide by the chain rule. So for our next step, oh, by the way, at this step, we're already 3 out of 6 points. If you can get to this step on integrating on both sides, booyah, already halfway through. Next, we're going to multiply the negative to the other side, and we get natural log of 3 minus y equals negative sine x plus c. We e both sides, and we get 3 minus y equals c e to the negative sine x. And we solve for y. Well, should we solve? Yeah, let's solve for y. Subtract 3 on both sides, negative y equals c e to the negative sine x. And it looks like I need more room, so I'm going to go to the other side and wipe out the first half of my question. Alright, and multiply the negative. Whoops, I forgot to write the minus 3 for subtracting 3 from both sides. And then multiply by a negative 1, and you get y equals a different c, e to the negative sine x plus 3. You can do negative c, but there's no point in doing negative c, so I just always change my c when I multiply by a negative 1 at that step. Now we have to use the initial condition to solve for c. And so we plug in 1 for y, and we plug in 0 for x, so that's e to the 0. And so we get negative 2 equals c1, so this is just y equals negative 2 e to the negative sine x plus 3. Wow. Answer acquired. Okay, Dakun, you missed the first part, and I assume a handful of people missed the first part because we're up to 27 from 12 when I started. But the AP test this is what's on it. If you notice, the first part of the test looks like it has star. The second part of the test looks like it has star. And the third part of the test looks like it also has star. So that's how much I know about what's on the AP test. I have no clue what it looks like. I'll be able to update it April 3rd, but you will also be able to update April 3rd. All right. Let's see if there is anything in here. Nope, not yet. People are just chatting. All right, I wanted to mob some more differential equations, so I brought these two guys up here. So they're just some sort of random examples, and they have the first two questions up here have the same misconception that a lot of people make. Because these are just separation of variables problems, so separating variables isn't hard. We get dy over e to the y equals x dx. And this is where things go poorly, because a lot of people integrate this, and they're like, natural log of e to the y. No. No, to integrate this, what we have to do is rewrite it, like so. And the right side is no problem. That's going to be easy integral. And now when we integrate, we get e to the negative y over negative 1, because we have to divide by the chain rule piece, equals x squared over 2 plus c. And now we can solve for y, multiplying the negative 1 to the other side, and getting negative x squared over 2 plus a new c. And then, like, natural logging both sides, and multiplying both sides by a negative, but at this point, this is probably an okay answer. On the AP test, you actually do end up matching to answers like this instead of natural logging because you lose some information when you natural log. YouTube didn't show you were live. Huh. I wonder if that has something to do with my issue with my stream key and getting a new stream key. Eh, hopefully not. uh, all right. Wait, don't you get a new C when you pull the -1? Pull up the -1. No. Can you do 9? Yeah, I can do 9. I wasn't going to do 4 because it was extremely similar to that one, so I'll do 9. I'll listen to Liam. Okay, so in 9, separate variables again, and we get dy over y, because we divide both sides by y. And we move the dx over to this side, and we get 12x cubed dx. Oh, on the last question. I don't remember. I'd have to go back and look, sorry. Natural log of the absolute value of y equals 3x to the 4th plus c. And this one actually ended up being easier than the other one, even though it looks like it's going to be harder, because we e both sides, and we get c e to the 3x to the 4th equals y. And we just plug in the initial condition. So we get 2 equals c e to the 0. So c is 2. So y equals 2 e to the 3x to the 4th. And we're totally happy. Yeah. All right. That's my initial differential equation reminder piece there. If anybody has any questions on questions I did here, I wish I could go back and look at what I wrote for this one to answer next question, but I know my answer's right because you can look up the answers for all these ones. So where I solved for plus c, it was the right plus c. I can't check if I should have updated plus c's. So I did put in these documents. I have this word problem-y dude here. I actually did 2 of the questions from this first part in my first video I made that I loaded to my website. But I didn't end up uploading one with these done because I got tired of making videos because I kept messing up. Oops. Can you do one of those mx plus b substitution problems? mx. Oh, I know what you're talking about. Trying to think if I can do that. Yes, okay. I know how to write one of those questions. All right, let's go to Kozar's question now. And dump this. Again, future streams are going to be at 1 p.m. I'm trying not to run over Cruisage here. It's a little bit of YOLO while we're not all communicating clearly. Okay, so what Kozar's talking about is find where y equals mx plus b is the solution to a differential equation and I needed to think about what these differential equations look like. There's something like this, 4x plus 3y minus 7. So I want to find where a line is the solution to this differential equation. And hopefully, this one actually works out here. Let's see. So, what I do, whoops, dy dx, I definitely don't want that part. Dy dx is m. Y is mx plus b, so I'm just dumping things into this question. 4x plus 3 times mx plus b minus 7. Cool. We distribute, and we get m equals 4x plus 3mx plus b minus 7. And then all we do at this point is we need our slope not to have any x's in it. So I factor out an x. like so. And then I just solve for what makes this parenthesis 0, because if this parenthesis here is 0, then I don't have an x in my slope, so I'm not a quadratic and I'm linear. So if I plug in negative 4/3 for m, I'm going to get 0 there, so m is negative 4/3. And all I have to do now is solve for b, so I just say negative 4/3 equals, I just made this whole thing 0 by plugging in negative 4/3 plus b minus 7, so I just add 7 to both sides, and I get, what, 5 2/3 equals b? Sweet. So my equation is y equals negative 4/3 x plus 5 2/3, or 17/3. Oh, did I forget the 3b? Oh, thank you, thank you, thank you, thank you. So let's fix that. We divide by 3 on both sides, and I actually get a different answer. Thank you for the good save there, folks. So b is actually 17/9, so that makes this 5 2/3 here trash. It's actually 17/9. Good save. Nice. Will the AP tell you to use y equals mx plus b? Every time I've seen them do it, yes. Every time I have seen that. However, they could say, where is a linear equation the solution to the curve? They could say that, and it would be possible. But every time I've seen them ask this, they've told you specifically they want it to be y equals mx plus b, because they want you to find m and b to make it work. So I would not anticipate that they're going to ask you that. Oh, Liam, hitting me with good questions. Can you do a Kecht problem? Sure. Let's do a Kecht problem. Also, good work, people. Thank you for not being blind followers like my Algebra 1 kids. No offense, Algebra 1. Because pointing out this mistake was very nice. So I didn't continue messing up. All right. So the way Keck problems are almost always started is they say the rate a city grows Why did I put an I in grows? I don't know. Is proportional to the number of people in the city. And the way we write this equation is like d people dt is proportional to the number of people. So the rate of change of the people is proportional to the people. And this sort of equation will always give us a Kecht sort of thing. So I separate variables, I move the dt over here, I divide by p on both sides, I get dp over p equals k dt. I integrate both sides, I get natural log of the absolute value of p equals kt plus c. I e both sides, and I get Kecht equals p. And that's how we get to Kecht. Now, let's say we'll make this like the question off that worksheet. So in 1920, Tacoma had how many people? Let's say 10,000 people. In 1950, there were 100,000 people. How many in, let's say, what, 2020? Let's go to now, and we'll do that. I dislike Tacoma. My wife's from Tacoma. Take that back. All right. So the first thing I do in these kind of questions is I do the lazy way out, which is I use the first condition they gave us, 1920, there were 10,000 people, and I say 1920 is t equals 0. And the reason I do that is it just makes it easier. I can make c 10,000 if I do that. So I can get my equation as p equals 10,000 e to the k t just from the first equation. Now, you don't have to do this. You can painstakingly plug in 1,920 for t and 0 for t for 0 time, and 1,920 for t, and then 10,000 for the output, and solve for the plus c at 0 time, like 0, 0, like the 0 AD, and do that painfully. But generally, just always use the first condition and make it the initial condition if you have the choice to do so. Okay. And then once we have this, 1950 is t equals 30. So I just plug in 30 for t. And I plug in how many people? 100,000 for p. I divide both sides by 10,000. I get 10 equals e to the 30k. I natural log both sides. Natural log of 10 equals 30k. And divide by 30, and boom, that's what k is. Sweet. That's really, really helpful, because now we know k, we know c, so we know our equation for the number of people is 10,000 e to the natural log of 10 over 30 times t. And the t we want is 100, because 2020 is 100 years after 1920. So I'm just going to plug 100 in here, and whatever I get, whatever, yikers, whatever that is, what is that? 10 natural, 10 to the 10 thirds times 10,000? I'm curious now. 10,000 times 10 to the 10 thirds. Let's see if Google can do order of operations correctly. Oh, there's a lot of people in Tacoma now, according to this problem I just did. Yeah, we've exploded, and now there are like 21 million people in Tacoma, which makes this not a very realistic problem here, because there are not that many people. All right, let's go back and look through questions. How are we expected to show work on an online test? Great question. April 3rd. I am confused. Times 999. Were people confused about the problem I just did? Or... And guys, I have no idea for the online tests how they're going to expect you to do it. If you've messed around with the new Pearson online crap, you can actually type in equations, and so they could have an equation editor that you could type in intermediate steps in, and they could grade you on each of those. So just realize that that's you just move a little fast. Oh, okay. I can do another problem with the same conditions a little slower if you want me to. Do you not put the c in the exponent from the kt plus c stuff? You can, but it's better to pull it down as a constant in front. I'm trying to decide what to erase, because it sounds like I should do another one of these. And I'll probably write fewer words. Let's get rid of this example. We can keep all the math because the kect is always the same. I need a bigger eraser. Okay. So we're going to do another city problem. Just real quick here. I mean, basically everything I'm doing here is pre-calc, so... Such is life. All right, let's say 1950 this time. There are 100 people at Liberty High School. And then in 1990 there are let's say 1,000 people at Liberty High School. And my question is 1930, how many people were there at Liberty High School? So this question I just made a little bit harder because in this question we're trying to go back and find an earlier time. Now, we can still cheese this the same way we cheesed the previous one. We can make 1950 our initial condition. It's just going to make 1930 a negative 20 in time, which is fine. So, I'm going to make population equals CE to the KT, but I know a couple things. I know C is 100. Because if I make t equals 0, 1950, then I can always just figure out C that way. So remember, when you make these equations, you get to choose what 0 is. And 0, you can say, is years from 1950. And you just need to... Liberty didn't exist in 1930. I know, this question's completely hogwash, but it's okay. So if our population moves up to 1,000 in 40 years, we build the equation like this. We plug in 40 for t, we plug in 1,000 for the population now. Now we just solve for k. So we divide both sides by 100. We get 10 equals e to the 40k. We natural log both sides. We get natural log of 10 equals 40k. And we divide both sides by 40 to get k equals natural log of 10 over 40. Once you have this, all you got to do is build your equation. Where am I going to put the equation? It'll fit over here. All right, p equals 100 e to the natural log of 10 over 40. Okay. Oh, this question's kind of dope, I think. Okay, and then what I want to find is how many people there were in 1930. So I want to plug negative 20 in, and I just realized I wrote a k here instead of a t. Oopsies. So I want to plug in negative 20 for my time into this equation. And so I plug in negative 20 here, and I get p equals 100 e to the natural log of 10 times a negative 1/2 for negative 20 over 40. And the nice part about this is we can just dump this on the inside as the exponent and then cancel the e and the natural log. If you're curious what all the steps I did last time, I just like doing this trick a lot. And if we do this trick, we know that it's 100 over, because it's a negative power, 10 to the 1/2. So it's just 100 divided by the square root of 10, which means the population in 1930, according to this ridiculous example, was 10 root 10 people, which is very ridiculous. There are something like 31 people in 1930, according to this question, at Liberty. Jack Poyle, nothing is real. I mean, sure, why not? So in theory, I could solve a Keck equation by using 1,000 for C and negative 40 for T. Yeah, absolutely. Yeah, yes. Yeah, you can set up anything you want to be your 0 point, and use that as your starting point, and then chunk through the question. And basically, all T is T relative to whatever you choose as 0, and that can make your question a lot like. I love when math has a bunch of different avenues to the right answer, because there's so much like beauty and symmetry in that. All right, so I did a bunch of pre-calc there. Does anyone have any other questions before I move to my cheesy ending piece here? Which I will explain in just a moment. Too many for the stream. Can you please do the landfill question? Well, we have finals. Natalie, very low probability we go back to school this year, I think. Can you do the landfill problem? Yeah, let's see if I can find the landfill question. So it's not this one. What else did I do? It was this. So Chelsea, I can't find that question in what I prepared today. If you like email it to me or something, I can cover it in the next live stream because I'm back Wednesday again to talk to you more about calculus. I'm going to be assigning something, and we'll probably talk about that, which should help, hopefully. Unless it is randomly on the screen here. Okay, cool. So let's get to mine, and yeah, guys, what's happening right now is completely insane, and nobody has any clue what's going on, and it's just going to get more and more sad. Like the next week's going to be pretty brutal. Early April's supposed to be the time when it hits us the hardest, our healthcare system and everything. So this is some pretty bad news bears stuff here. Okay, so the first thing I wanted to do for the end part here is I want to do like a random AP question. So I just picked this random AP question because I don't believe it's one we've done this year, and it's a good amount of review. And I just want to mob this out, and then I'm going to talk about what I'm assigning and that sort of thing. So first piece is show that this is the derivative. And so how would we show that? Well, we'd take the derivative of this equation. And if you remember implicit differentiation, the derivative of y squared is 2y dy dx. The derivative of 2 is 0. And the derivative of xy is a product. And so we get y plus x dy dx. For derivative of the first times the second is y. And first times the derivative of the second is x dy dx. Then we just solve for dy dx. We subtract the x dy dx over to the other side. We get 2y dy dx minus x dy dx equals y. And we factor out dy dx. And we divide by that junk. And lo and behold, we get exactly the answer we wanted to get. Huzzah! And I know you guys were asking about these kinds of questions, but you're probably not going to have show that questions on this AP test. But again, I have no clue what's on this AP test. Maybe they'll find a way to make you do this. I don't know. All right. Part B says, find all the points on the curve where the line tangent to the curve has a slope of a half. So for this, all we're going to do is set a half equal to the derivative equation, because slope is derivative. And I just solve this for x and y. So you can cross multiply here. Wow, I like when we get to use cross multiply because it's like a good meme. And we subtract 2y from both sides, and we're like, oh, okay. So it's when x equals 0. Cool. That was easy. So entertaining there. And you might notice it's kind of obvious that it's going to be something like that because the only thing that can make these the same is when x is 0. So, nice. Part C says, show that there are no points x and y on the curve where the line tangent to the curve is horizontal. Horizontal tangents are critical points like maxes and mins. So what we need to say is, like, prove is that there are no places where the slope is 0. So let's test it. So we have this equation. And for this equation to be equal to 0, y would have to be 0 because we need the top to be 0 here. However, if we plug in 0 here for y, we're also plugging in 0 down here. So we're getting 0 over 0 minus x for our plugged in piece here. And when x is 0, this is complete trash because we get 0 on the bottom. Additionally, if we plug 0 back into our original question, we get 0 equals 2 plus 0. You may know that 0 is not equal to 2, so that's complete garbage. So while it didn't fail our derivative at all points, it only failed it when x was 0, it did fail our original equation everywhere because 0 can't equal 2. So y equals 0 is not a plausible answer to this question, and therefore it's impossible to have critical points. Impossible to have the top of the derivative equal 0. And on to part D. It says, let x and y be functions of time t that are related by that equation that we've been dealing with the whole time. At time t equals 5, the value of y is 3, and dy dt is 6. Find the value of dx dt at time t equals 5. So, in this one, things change a little bit, because instead of taking the derivative of this with respect to y, or with respect to x, like we did up here in the top part, we're actually going to take a completely different type of derivative. We're going to take a related rates kind of derivative with respect to t. So we still get a 2y when we take the derivative of y squared, but instead of getting a dy dx, we get a dy dt. And we know to do this because they say time t, they're functions of time t, find dx dt, find dy dt. So they give us mad hints that we're going to be taking the derivative with respect to t. Derivative of 2 is still 0. And the derivative of xy is y dx dt plus x dy dt. I still have to do the product rule here, but unlike when I did it above, the derivative of x with respect to t actually is something instead of just a dx or a 1. Okay, now we have this beautiful differential equation here. We can just plug in the points they give us. So they tell us y is 3, so it's 6. They tell us dy dt is 6. Cool. Left side done. Right side, y is 3. dx dt, I don't know. X, I don't know. Well, I do know, but I'm going to have to figure it out in a second. And dy dt is 6. So that's all the stuff you know right away, just given from the question. So we have two unknowns, but one of these we can absolutely figure out, and that one is x. Because in our original equation, y squared equals 2 plus xy. If I plug in 3 for y, I get 9 equals 2 plus x times 3. And this is very solvable for x. So all I do is subtract 2. I get 7 equals 3x. So x is 7 over 3. Then we plug in 7/3 into this equation. 7/3 times 6 is just 2 times 7, so that's 14. And the left side is 36. We just divide. Let's get rid of this now. We just divide or subtract 14 on both sides, and we get 22 equals 3 dx dt. And we divide by 3, and we get 22/3 is dx dt. And that was the final hurrah of this question. It was a, I would argue, easy related rates question, but had some extra extensions in there. There was no like hard word problem reading stuff, but there was using both the original equation and the derivative to solve most of the parts of this question, which seemed like a good question for reviewing calculus-y stuff. So, what this was and what I plan to do is do a big long, not a big long, but just a random AP question at the end of all of my streams. So every Monday and Wednesday until we go back, or the AP tests. And so this was our first installment of that. All right, Daikун's been slamming me with questions, so let's look at Daikун's question, because this is some like old school stuff here, going back to last unit. What Daikun is asking about is the whole sum notation for integrals, and he wants to integrate or convert something like from 1 to 2 of x squared dx. So this is a definite integral. He wants to convert this to the limit notation. And all you have to do for this is, we always have the limit as n approaches infinity, so we want infinity rectangles, so number needs to go to infinity. The integral from I equals 1 to n. And this is the integral sign. This is what the integral sign is. It means sum together a whole bunch of rectangles. And we need to put in x squared, so we're going to have something squared. And our dx is always our width of our interval divided by the number of rectangles. So it's in this case, the width of the rectangle is 1, and we're dividing by n rectangles. And then our starting value, because I started at the integral from 1 to 2, is 1. So I'm going to do 1 plus. And my current rectangle I'm on is going to be my increment times my dx. And so this is my current x value. This is my current dx value. Or my dx value is the same for all of them. All the rectangles have the same width. This is what increments with your counter here. Those of you in coding classes, this is exactly a for loop, but it's an infinite for loop, so it's a while loop. But this is how you convert from definite integral to limit notation for these guys. And I'd say this is reasonably low probability to show up on the AP test. We'll see. We'll see. It's 45 minutes, but yeah. Okay, yeah, let's talk about schedule stuff, since there's some disagreement and some fake news in there. Guys, the schedule, Monday is like, oh, gosh darn it, is a lesson stream like this, and we're going to be 1 p.m. stream with an assignment. I'm going to be doing more online assignments and Barron's book assignments, but today's is actually a worksheet, and I'll show it in a second. Wednesday is the same. It's the same thing. 1 p.m. stream and an assignment. And last but not least, we have Thursday. And Thursday's just open question stream. So these ones are a little more structured. I'm gonna be teaching something, blah blah blah. Thursday, I'm hoping to do a little more like one-on-one. Like you can ask very specific, random questions that aren't specific to what we're talking about. Did I lie about that? Wait, crap. Thursday's Algebra 1, swear word. He was right. T-Bone was right. Friday is that open stream where I talk about that kind of stuff. So these are more like smorgasbordy. You should come to me with questions, email me questions, link me questions, whatever. But I will answer any sort of random questions then. Whereas on Mondays and Wednesdays, I'm going to have more structured stuff and be asking you to do things. And sorry, Tim, I did lie to you. If I make Thursday my live stream, then I'll be doing Algebra 1 and Calc at the same time, and maybe that is the right play. We'll see how many people actually show up to these open question streams. So it is Monday, Wednesday, and Friday are all streams. It's also a 1 p.m. stream Friday, but it's less structured. I'm not going to prepare a bunch of stuff. I'm just going to answer people's questions. So I'm willing to work with people relatively one-on-one if that's how people come in or whatever like that. Mr. Kennedy, can I speak to your manager that doesn't... Who has a schedule right now? Yikes. Okay, so the last piece is... I got plans on the Friday. Could you move the stream back? Yeah, I'll move it back to the following Friday. All right. So what I'm asking you guys to do, and the practice I have prepared for you and posted on my website, is this. It was my Chapter 6 review worksheet, which I did not give to you because we didn't quite get here. It has a big mashup of calculus-y, differential equation sort of questions on here. I want to answer questions, and I'm probably going to end up going over the potato problem. You may have heard about this one. This was a good meme from a few years ago. And yeah, I'll be happy to answer any questions from this next time. I'll probably end up going through a fair amount of this next time since this is the homeworky thing. And that's what's up. Let's see if there are any questions. Why do I have a manager? Yeah, I don't have one. About the AP test grade, will that still be? Yes. Test grade bumping will still be in effect. Guys, I am just as clueless about the AP test as you. If you've read what's on the website, you know as much as I do. They don't like tell me anything, so I'm not changing any of my procedure that I don't have to. The one on your website doesn't have the number 4 written out. Huh? I swear I uploaded this exact document. I will double check that and fix that. Oh, I may have picked the wrong one. It has a bunch of blanks. Huh. I wonder if it's the word thing. I wonder if I save it as a PDF, if it'll look better. I'll try that. Are Liberty braids going to be pass-fail? Probably. That's my guess. I could get in trouble for saying anything definitively, but probably. All right, yeah, I'll check that link and make sure it's okay. It might just be a PDF issue. Yeah. Do we still get credit for this semester? I don't know. I have no clue, guys. They really tell us almost nothing. Even our principals, like, man, last Friday was such a hilarious thing because the administrators were sitting in the hallways, like with their arms up, like, we don't know what's going on. 6 feet, please. And that was all we were doing at work. So, yeah. Sorry, folks. I wish I could tell you more, but I know nothing. Do pass-fails have an effect on your GPA? No, they don't. They're like not having a GPA. for that semester. All right. Well, ladies and gentlemen, uh, it was a nice talk here. I'll see you again Wednesday. We should have a lot more to talk about because I have an assignment and stuff. And yes, this is a crazy weird semester. This is a crazy weird time. We're living through history. This is like more impactful than like a September 11th thing. So this is the craziest thing that's happened in my lifetime. And stay safe and tell your loved ones that you love them and all that sort of stuff. And holler.